Well, thank you very much for everyone for the time to be here with you sharing my story. So I will start just by recognizing UNISEC's leadership, like in creating this type kind of activities and promoting the capital formation in a global scale. I think this is one of the most important aspects in any of the challenges that we are trying to achieve in the space field. And I want to emphasize something from now, but I will try to give that idea during my talk. And is that CLTP is a cornerstone for many professionals. So as you can see, we are heading to the 15th CLTP. So many of the people that we have participated in this program, we are now working on the space field, as you can see from the previous presenter. So many colleagues are doing the amazing things in the space industry, in the academia. So I want to thank for UNISEC and Japan to have this program and to open the opportunity for many people to start doing something in space. Okay, so just my personal background, I will try to be brief on this. I'm come from Mexico, so I study both university and master degree in Mexico, in particular in Mexico City, which is the capital. So I study at National Autonomous University of Mexico. And since the time I was there, I was very interested in the developing technology, in particular related to space. I tried to get involved in space activities since I was a student. Uh, I did not study myself in a career in the space field itself. I started with the electronics, and then I moved during the master to the scientific instrumentation. But all the things that I did there, I were involved with the space science mainly. So I had a chance to work with the radio telescopes in Mexico, with the charged particles detectors in Mexico, and also in Argentina. So since the time I was there, I was like trying to get into orbit, right? So I will go to that point later. And before that, since I was a child, I can say that the earliest moment I have in my mind when I started being interested in space, it was when my father teach me how to do like matchstick rockets. So it was kind of a rainy day, actually, like maybe similar like today in Japan. It was rainy, and at the end of the day, we went outside and we started to building like very small rockets with matchsticks. And for me, that was very interesting, and it was like the spark, like starting my interest about space technology. So from my professional experience, before CLTP, I was working, and after graduating in Mexico, I was working as a geosatellite operator. The name of that national company is Mexat, but I was mainly doing operations for geosatellites. So this is a completely different story from CubeSats or other small satellites. So I was like, let's say, kind of working in the old space way. I had a chance to go for training to the US to Boeing and Orbital Science Corporation at that time. Now it's Northrop Grumman, and it was actually my first time to enter a clean room. It was a huge clean room full with the geo satellites. Probably they were assembling three or four at a time, but everything I could see there, it was just at a distance. I couldn't touch anything. I couldn't go into details. Even if I asked, they said you can you can know up to this point, but beyond that, even if I continue asking, they said that is reserved for the company, right? And of course, that's true because that is the uh, capabilities they develop, and they were just selling a service for us. After that, I worked for the Mexican Space Agency on the Human Capital Department. And during my time there, I was pushing the uh, space university studies in Mexico, in particular for technology in space. So in Mexico, at that time, maybe 10 years ago or 15 years ago, there were very few universities and very few programs related to space technology. For space science, we have a long history, I should say, from probably 15 years ago or more than 15 years ago. But in the case of developing technologies for space, this is just started probably around 15 years ago or 10 years ago. So then at that time, I was trying to help university programs to start, and actually, CANSAT was one of the programs we took part to trying to transfer it into Mexico. And actually, now I could say that the CANSAT programs in Mexico are like there are programs across the country. So we help to start developing those. I will go into more details about this. But that was basically my main activities related to space education in the Mexican Space Agency. So after that, after I completed the doctor degree in Japan, I have been working for Mugin, which is a robotics company for Nihon University, and currently I'm working for Deloitte. Okay, so regarding the CLTP experience, I would like to start just putting a strong emphasis on the hands-on role and being part as of a- let's say like starting with the systems engineer, like it's putting you in the role of a systems engineer, and because you have to start balancing and considering designs for the not only for one section of the project you are developing, but you need to consider everything at once. And I think it also helped me to face from a different perspective multivariable engineering challenges. So this is, I think, one of the key aspects of CLTP. And on the other hand, this marked like a shift in my career because, as I said, when I was working, for example, in the dealing with the geo satellite systems, everything was built by somebody else. So I didn't touch anything. Of course, I did like create procedures and create some kind of not exactly coding, but like scripting, but it's not actually building the system from scratch or building the system from the concept. So I think this was the key or the pivotal shift in my career when I participated in CLTP 5. So just to summarize the story through images, as many of you know, CLTP is characterized by building and having the hands-on experience as part as the one of the key central roles of the course. And yeah, I remember we went to shopping for some sensors to define our missions or to complete our missions, then integrate everything into the CANSAT kit that we received, which it was the iCANSAT. And then we had the opportunity. For me, it was the first opportunity to actually be this close to a vibration test. When I was working with the geo satellite constellation, I only could see like the reports and outputs from the test itself, but I didn't had experience to be in the test place. So for me, this was the first vibration test that I experienced. And with Kansas, we didn't go for the thermal vacuum test, but we did a thermal cycle test, which was actually very nice to experience as well. And then we built the paper rocket. So that was also another interesting story. So I never imagined like creating paper rockets. I actually, at that time, I was remembering my kid experience with the matchstick rockets. So if you think about it, it's kind of similar, but a little bit bigger in size. But the purpose was just perfect for launching our concept. And then, yeah, we launched the concept, we operated, get some data, and finally we just received the certificate of completion of the CLTP 5. So these were the five, I mean, the people that we were participating in the CLTP. So many of them I have the chance to meet again. Probably only Hamad, I had not been able to meet it after the CLTP. But everyone else I had the chance to meet, and even in conferences or during some space activities in Japan or outside Japan. So it's been an amazing story. Like after 10 years, we still have the contact, and even if we don't see each other frequently, we have the contact, and it's amazing when we met at a place such as a conference. So at that time, Professor Totani was the instructor, and then we did everything at Uematsu Electric. So it was very probably, I should say, lucky, because at that time we experienced the test of a combustion test of a rocket engine. So I will just quickly show you a video I took on that day, and it was an amazing time because it made us feel like we were doing real engineering, real space engineering. Yeah, this was of course not part of CLTP, but yeah, it was something interesting to see at a close distance, and later just learn a little bit about the test they were conducting there. All right. Okay, so I would like to mention how CLTP shaped my career, or what were the key aspects after uh, taking the CLTP. So first of all, uh, I would like to emphasize like the teaching of it teach me how to create a space system, even if the CANSAT itself couldn't reach space or couldn't reach orbit. But the fact that it was a hands-on experience, it really helped me a lot to understand the challenges, in particular like debugging, like creating software and running tests over and over again until it started to work. So this is one of the important aspects of the CLTP program, and I think uh, one of the challenges here is completing everything on time. But it's on the other hand, it's also part of the experience, because in many projects, as you may know, that we always run out of time, and we have kind of a constrained schedule environment. So this was a very good example and a very good practice to learn how to deal with those situations. It also integrated into a global ecosystem. So uh, as you know, you met many people from around the world. You met instructors. You met and you start making connections, which is very important. And not only for that activity or during that time, but for the I should say for the rest of your life, because with many people that I met from there, we're still in contact. Actually, some of them are colleagues now in the space business. So it's an amazing opportunity. Uh, it also boosted my professional confidence. I mentioned that I was dealing with like debugging hardware, debugging software, and probably just to give more idea of the previous question from Rei Kawashima-san about the difference between CubeSats and CANSAT. I think CANSAT is still very helpful for young professionals and for people starting involved into the space technology field, because you have to make you have to create your errors, and you need to how to solve those errors. You need to face such kind of challenges, and I think it's easier doing it on a CANSAT than even if a CubeSat is like decreasing in price. But I think people feel more confident if they break a CANSAT rather than if they break a CubeSat or a flight hardware part. So I think that's one of the key advantages of CANSAT training. And yeah, it also influenced my trajectory. So it helped me to go stage by stage to reach projects with more complexity, with bigger challenges. So after that, I had the chance to launch a 23-kilo satellite, and after that, a 6U CubeSat, which actually was deployed from the HTBX vehicle just last March. And yeah, it's I think everything started from this point after CLTP. So okay, after CLTP, I will just give you a little bit more details of what I've been doing. So I try to summarize in images, and just I would like to try to explain every of these four aspects. Hopefully, it will kind of give you the idea of what I've been doing and the importance of CLTP after that. So, sorry. So after I finished CLTP, I returned to Mexico, and I started like creating the uh, our own concept training programs in the country. So at that time, I was still working at the Mexican Space Agency, and I have the chance to create several courses. And from North to South Mexico, I traveled to different universities. So we conducted the training, we conducted both theoretical and practical, and we launched the concepts either by using drones or by using other methods such as balloons. And then I should say like I helped to build the current ecosystems of the space education in Mexico. And for me, it's amazing to see that now there are many institutions conducting these activities. I also learned about a different challenge, which is not being participant, but you being the teacher, or you teaching, or you co-creating the course with other professors. So this was a different challenge because one thing is for you to be the student, and the other thing is for you to be the teacher or the professor. So it was also very enriching activity. It also I learned from that a lot. And after that, I decided to pursue my PhD in Japan. So I came back here in 2016, and I started at QTech, the doctoral course, and I had a chance to participate in this 23 kilo satellite. So it was very challenging because we did it everything in 16 months. And I was at that time working mainly on the mission experiments. So with a charged particle detector, with a Langmuir probe and a magnetometer that I created by myself. And everything, it was very hard, but we could launch it and then start operations. So it's really an amazing moment when you hear the signal from your satellite, something that you started building months ago, and now it's in space. So then I graduated in 2020, and then, but at the time there was a COVID situation. So originally I was planning to go back to my country. However, the situation became a little bit difficult for traveling, and then I decided to stay in Japan and to start looking for opportunities. And at that time, I had the chance to move to the industry in a robotics company. So unfortunately, I can mention too much images about my experience there due to confidentiality, but I can say that I also learned a lot. Working on the industry in a different field and space, it might sound like too different, but it's actually not. So I was conducting testing as well. I was doing mainly hardware development, and I was working as a reliability engineering too. So I conducted vibration tests, I conducted thermal cycling tests, I conducted electrostatic discharge testing, and I have to comply with the national and international standards because these systems are built in Japan, operate in Japan, but are also exported outside Japan. So it was a very enriching experience, and actually everything that I learned before, I could apply it here, even if it was not a space activity. So yeah, it was also a very nice time during that time. So after I moved back to the space, so I have the chance to return to working on a satellite mission. This time was a 6U CubeSat. And at that time, I was invited by Okuyama Sensei, which was also the sensei that I was with in the university. He moved to Nihon University, and at that time, there was a chance to participate in a new project. So I joined. It was also a very good experience. So we have the opportunity to conduct irradiation tests in a in a facility that I never experienced before, which was using a cyclotron for irradiation testing. We did a calibration for a charged particle detector too, which was part of one of the missions. And this was also very challenging because this satellite was launched by the first HTBX, and that mission made it to be very complex. Also, it was launched by the H3 rocket, which is a new rocket from Japan. And it was also deployed by the HSOT, which was the new satellite deployer. So everything was new. There was a lot of uncertainties. The vibration environment was crazy. But in the end, we could finalize the project. And as I mentioned, it was just launched. It was launched on October last year, but it was deployed from HTBX last March. I don't know the details because I stopped working on that more than 3 years ago. But from what I know, it's like the satellite is transmitting beacon, and I mean, it's alive in space. So for me, that's also very good notice. And yeah, it was very nice to see that another part of piece of hardware is working in space. So my current activities, unfortunately, I cannot say too much because the project I'm working is confidential, but I can say that I still conduct satellite systems engineer. So mission analysis, like orbital definition, power budgets, conducting trade-off between different subsystems. I've been doing also prototyping and testing. So actually, 2 or 3 weeks ago, we were conducting irradiation test again. Uh, and I have the opportunity to continue doing research. So last year I was attending AIC after probably 6 years or 7 years without attending AIC, but I returned to attending the space conferences, which is also very nice to activity and being able to publish papers and yeah, conducting research about the projects we are developing. And yeah, just to finalize, I would like to say that yeah, CLTP I think it's something that it matters very much nowadays that we are in the world of mega constellations, of sustainability effects, of new applications based on small satellites, on missions reaching the moon, going back to the moon. So I think everything that you can experience during CLTP time, it's very important nowadays. So you still be able to conduct mission concepts. So you will do hardware debugging a lot. You need to conduct rigorous testing, and something very important, you need to do failure analysis. So not everything that we build starts to work perfectly. Even after several missions, I should say like there is always a risk that something that happens, and in particular because we are working with not and sometimes not space grade components. So for CubeSats and small satellites, we mainly use COTS parts or commercial or industrial grade parts. So having your mind open for the failure is something very important, and I think experiencing this with a hands-on training such as CLTP, it gives you the tools to start doing that and going further into solving those kind of situations. And finally, I think for the leaders, I would like to emphasize the importance of creating a network, to having a wide network of contacts. You never know when you will need something or you can participate helping somebody else. Uh, it is very important to embrace the failures. So, of course, we don't want to fail in space. We don't want to fail in any activity. But I think it's very important learning from errors, learning from your past activities, and face everything with the confidence that you can solve it. And one last thing is, I would like to mention that it's very important to take the knowledge home, in particular for our countries which are starting or going to the space direction. So spreading the knowledge, sharing all the experience that each of you will have or each of you have is very important for the new generations, for the people that is coming after us to continue and grow up the activities in our countries and in general in the world, because yeah, we are also contributing to space world activities. So thank you very much. This is everything I have for today. So if you have questions, I will be happy to try to answer those. Thank you.